All right, let's go and take a look at problem number 4. So problem number 4 gives us a value for voltage capacitance with respect to time, then also gives us a capacitance value. And they want us to find the complex impedance of the capacitance and also find the phasor voltage and current. And they want us to write it as a function of time. Okay? And then construct a phasor diagram as well. So let's see what that means for us. So let's write out what we know. So V of C, capacitance is equal to 10 microfarads. We know that V of C with respect to time is going to be V of M cosine omega t plus a phase angle. Let's look at their equation they gave us. They gave V of C at t is equal to 10 cosine 2000 pi t, and that's it. Okay, so from here, let's pick apart what they gave us. So V of M is going to be equal to 10. Our omega is going to be 2000 pi radians a second. It's everything that's before the t in here, okay? So 2000 pi. And then our phase angle is 0 because there is no plus part behind it. No plus or minus part behind it. Okay? So let's write our phasor voltage. So if we do the phasor voltage, so V of C will just be 10 at angle 0 volts. And that is the phasor voltage. Now let's find the complex impedance. So the complex impedance, Z of C, is going to be negative J over omega C. So negative J will be 2000 over 2000 pi radians a second times 10 microfarads times 6. And I'm getting negative J 15.915 ohms, which is the same thing as saying 15.915 negative 90 degrees. Okay. And that's the complex impedance for the capacitance. What else do we need to find? Current. So let's find current. So I of C will be V of C divided by ZC. Okay. Well, since we're dividing, let's go ahead and use phasor. So 10 at angle 0 for the voltage, 15.915 at angle negative 90 for the impedance, which we just found. So 10 divided by 15.915 0 minus negative 90 degrees. What do we get there? And I'm getting 0.628 at an angle of 90 degrees. That's my current for C. Okay. But let's check it with the Iceman. Okay, so ICE means current leads voltage in a capacitor. So what that means is that it's going to, the angle for the capacitor current has to be greater than the angle for the voltage by 90 degrees. Well, let's take a look. Here for the voltage, we have 0 degrees in the voltage. And here for the current, we've got 90 degrees. So that works out just fine for us. And I forgot to drop in amps right there. Amps and ohms. So now let's write this out as a function of time. So if I write the current as a function of time, using my model that I had up here, I'll write I of m cosine omega t plus the phase angle. Then I can write I of t will be equal to 0.628 omega. The omega is going to stay the same. So that 2000 pi t. And now we have plus 90 degrees for that current. And this is our I of t equation. So this is a capacitor current with respect to time. Okay. So it's really not too bad. It's just a couple equations and just kind of grinding everything out. But I'll see you in the last problem for this review session.